Now we can see, right?
Yeah, yeah.
Okay. Let's paraphrase the problem.
1 kg stone.
Yeah, you just write in your paper whatever you want.
Yeah. 1 sec. I'm going to get a different pen.
The mass is 1 kg and is thrown with a velocity of 20 meters per second. So we can put U because U stands for initial velocity. So it's more like U is 20 and it travels a distance of 50 meters and the velocity becomes 0.
Yeah.
Yeah. So there is, since the velocity reducing, there is some force which is stopping it, right? And force and acceleration are related. How is force and acceleration related?
When the force is less, then the acceleration is lesser.
Force is equal to m into a, right?
Yeah.
This is what called, this is some famous law, right? You come across this one?
Yeah.
Okay. So if acceleration is known, then the force which is producing that acceleration will be known. Okay. So here you have to find force of friction. So can we find acceleration from this information? Acceleration from this information. Mass is 1 kg.
Yeah.
U is initial velocity, right? V is final velocity, and S is the distance. So there are 3 equations, right? 3 equations of motion.
Yeah. I don't know the third one.
Sorry?
I don't know the third one.
No, I think the 3 equations of motion I told you, right? V equal to U plus AT. Have I told you this one?
Yeah.
First one. And then second equation is S equal to ut plus half AT square. And then V square equal to U square plus 2AS. Okay, here U is known, V is known, S is known. So among these 3 equations, which one will you use to get A?
The first one.
First one, T is not known, right?
Yeah.
So what about the other ones? Second also T is there.
Yeah.
Okay. What about the third one?
The third one.
In that V is known, U is known, S is known, everything is known. Except for?
Third one.
Yeah. So find A from that. So use the third one. From this I have to get A.
Yeah.
Do the calculation.
The V is the velocity, right? Or is V the weight?
V is 0. So 0 square is 0. And U square is 20 square plus 2A into S is 50. So from this I'll get A as 400 divided by 100, right?
Yeah.
Minus 4. minus sign, meter per second square. And why is the sign minus here? The sign is minus, right?
Yeah.
So what does it mean? What is the significance?
It means there's no acceleration, it's
No, it means it's deceleration.
deceleration.
Deceleration, because velocity is decreasing, right?
Yeah.
So velocity decreasing means there is deceleration. A less than 0 means velocity is decreasing. Okay. A greater than 0 means velocity is increasing. Right? Here velocity is decreasing. 20 to 0. That is why it's negative. Okay. Now what is the force? Use this one. So from this you get force as mass is how much? 1 into acceleration minus 4. So this is equal to minus 4. What is the unit?
Newtons.
Yeah. And what does the minus indicate?
That the force is decreasing.
No. Force is retarding. See, the force can either increase the speed of the mass or it can decrease the speed of the mass, right?
Yeah.
Similar to acceleration, negative means it's a retarding force. Like when you're throwing a ball from the ground, the velocity is going to increase or decrease.
Increase.
No, when you're throwing from the ground you're throwing up.
Decrease.
Yeah, it's going to decrease. That is because the force which is acting on the ball is downwards and the velocity is upwards. And when it's coming down, the velocity is going to increase because at the topmost point, the velocity is 0. After that, it will turn back. When it turns back, the direction of the velocity and the pulling force, which will give an acceleration, are both in the same direction. Okay. So suppose this is the surface on which the thing is skating on the ice, 20 kg. So it's skating like this. The friction force is acting this way, right?
Yeah.
The velocity is this way. That is why the velocity keeps on decreasing because the direction of the force is opposite to the direction of motion. So it will try to reduce its velocity.
Oh, okay.
Because the the force is trying to stop it. And the direction of force is same as the direction of acceleration by this relation. If you could m into a, whatever the direction of acceleration is same as the direction of the force. So acceleration is also opposing the velocity. That's why the negative sign is
there. Okay.
That's what happens when you throw a ball up, the force is downwards, the velocity is upwards. So the velocity keeps on decreasing. And when it turns back, velocity is downwards, force is also downwards. That's why the velocity keeps on increasing.
Okay. Yeah.
Shall we move to the next one? It's clear, no?
Yeah.
Okay. First, draw a figure so that you'll understand the problem better. First step is paraphrasing. This is a good enough picture, right?
Yeah.
Okay. So the engine, it's 8,000 kg.
Yeah.
And then each of them is 2,000 kg. Okay, and this engine is obviously pulling the one, so it is exerting a force of 40,000 Newton. Okay, and the friction force is 5,000
Yeah.
Newton. So, so that the direction of acceleration will be this way, because the direction F equal to m into E, right? So the net force will decide the direction of acceleration. The net force is towards right, because the pulling force is 40,000 and the friction force is 5,000. So there is more force on the right side. So and thing will move on the right side. The direction of acceleration is towards right. Now find A. So this is the first step, paraphrasing of the problem. Next step is to try to solve it.
Okay, so the net accelerating
First thing is find net accelerating force. That is the first one.
yeah.
What are the forces acting on this full thing? The train, full train.
Friction,
Okay, other than that,
gravity.
that's the vertical direction. Uh, in the vertical direction, there is gravity, and then what will compensate that one? Something should balance that, right? Because the train is not moving vertically,
Yes.
so some other force should balance it. What is that force?
I forgot what it's called. The normal
Normal
reaction.
reaction.
Normal
Uh,
reaction, yeah.
yeah, normal reaction will balance the vertical weight, uh, mg. Okay, so forget the vertical one. What about horizontal?
Uh,
How many forces are there?
2.
Yeah. So, and so what is the net force?
The force of
Yeah.
the engine minus the friction.
So how much is it?
35,000.
Yeah, and towards right.
Yeah.
The F net is 45,000 Newton, and the direction is towards right. And second, acceleration of the train.
Uh,
Use Newton's second law.
Force is equal to mass times acceleration.
Yeah.
So 35,000 is equal to. Oh, then you have to add all the masses together. It's the
Because
total.
35,000 is acting on the full thing, so you have to take the full mass.
Oh, okay. So it will be 10,000 plus 8,000, 18,000.
So from that, what do you get E as?
35,000 by 18,000.
So less than 2. It will be
Yeah.
approximately 1.9 or something.
Mhm.
Right. So let's leave it at that. Force on wagon 1, force of wagon 1 on wagon 2. So here wagon 2 is there. So this is the force with its force on wagon. So wagon 1 will be pulling this wagon 2, right? So this force we have to find out.
Yeah. Okay. Wait, so you have to
So
find out.
that is same as finding this force. See, there is a connection between W1 and W2, right? So whatever the connecting thing is, it's like you can think as a string. It's not exactly a string. It's sort of a connection, right? That connection will pull this W1 will pull W2 and W2 will also pull W1 because of that connection. It's like two things are attached by a string. Okay, even if one of them is pulling, the other one is also pulling the other one. Got it, no? If you have two masses, okay, and there is a string between them, and the whole thing is moving this way, and this is the
Mhm.
this is the way you are applying the force. Okay, and this is the direction of acceleration. So this thing will pull this guy like this, and this thing will pull this guy this way.
Yeah. But the first force is stronger.
Yeah, there will be a net force in this direction. So if you take only this one, uh, this thing is getting pulled by okay. If you consider this thing is getting pulled by this one, okay, and this thing is getting pulled by this one. So both are pulling each other. So this force is same as this force. That's what I want to say. The force with which this is getting pulled is same as the force that this is getting pulled. Okay. So if you can find this force, that is same as that force. Find this force, the net force acting on this is known, right? On the right side is 40, and here it is.
Yeah.
Say let's call this force something like P, similar to tension.
Okay.
Let me call this force as P, okay, and some friction force is there at the bottom.
Yeah.
So if you take uh, this as my system, the engine in the first one, okay, what are the forces acting on it?
Friction.
Okay,
The force of the
40,000
things.
40,000 is towards right?
Yeah.
Is there any other force?
Uh, the normal reaction and gravity.
No, that is vertical direction. That you forget it.
Yeah.
Horizontal.
There's the force of all of the other trains.
Tension, that is T. That is T, right?
Yeah.
So now we have to write that equation. So 4,000 minus T, 4,000 or 40,000? 40,000,
Yeah.
40,000 minus T minus friction force equal to mass, that is mass of the engine plus W1, right? Into
Mhm.
E. And what is the friction force?
5,000
But
newtons.
5,000 is for the entire thing, right? 5,000 is for the entire train.
Yeah.
Uh,
So
and
is that by 6?
no, so the friction force 5,000 is the entire train. So we have to find the friction force corresponding to this part. So 8,000 plus 2,000 is 10,000 out of the total weight of 18,000, right? So and friction force is proportional to the mass. So let me explain it. So it is 10,000 divided by 18,000. So this friction, and let me write as friction force 1. Okay, so this is equal to 10,000 divided by 18,000 into the total friction force, that is 5,000.
Okay.
10,000 is this mass, 2,000 plus 8,000. The total mass is 18,000. So it is that fraction of the friction force. Okay, and this is known, that is 10,000, right? Okay, and acceleration is known, right? From the previous one, 1.9 or something. From this you can find T. calculations you can do later, but this is the method.
Oh, okay.
Okay, see, friction force is mu to normal reaction,
Mm-hmm.
and normal reaction equal to m into g.
Yeah.
So it's proportional to the mass. So whatever the 5,000 is for the entire train, so this part will experience a friction force of that proportion of mass. So it's 10,000 divided by the total mass into that total friction force.
Okay.
All right, that's it. The truck is at rest. Okay,
Mm-hmm.
so if some force is acting on it, right now there is no force.
Yeah.
Okay, but if some force is acting on it, what is the force that will stop? See, there is some force acting on it and still it's not moving. That means what? Where is the other force? Some force is there. Suppose wind is
Yeah.
blowing. Suppose wind is blowing this way, so that will exert a force, right? So let's say this force is there, but still it will not move, right? Only
Mm-hmm.
the force is strong, then it will start moving.
Yeah.
Even for a mass on even for a book on a table, if you try to push it slightly, it will not move. You have to push it with a little bit more force, right? Then will it start moving. So what do you think it's opposing this motion? Why is it at rest even with the force applied?
So both of the forces cancel out each other.
What is the other force? One foot is something is pulling it or pushing it. What is the force
Yeah.
that's opposing it?
The mass of the truck and friction.
Mass is in the vertical direction. It's a friction force.
Okay.
Right. See, when the thing is at rest, the tire is not rotating. Okay, and if the tire is not rotating and you're just trying to pull it, the tire will start to skid or got it, no? See,
Yeah.
when the tire is rotating, it will move. Okay, but here the tire is not rotating. It is just like this, and you're trying to move. So it is like sliding. When it is
So
sliding, when you try to slide it, there will be a friction force in the opposite direction.
okay.
That is same as if you have a mass on a surface. You try to pull it, there will be a friction force this way, right? That's because you're trying to sort of slide it along the surface. So similarly, when the tire is not rotating, when you're trying to pull it this way, it's like sliding,
Yeah.
translating motion. So that will create a friction. So that friction is good enough to oppose this one. If this is small, once you keep on increasing, it will start moving. That is same for this mass on the surface also, like a book on the table. When the force is small, it will be at rest because the friction force will cancel that one. But when if it keeps on increasing, it will start moving because friction force has got a limit. You know, increase beyond certain value.
Okay.
The two opposite forces of F and friction. But even if F is zero, when both the forces are not there, there is one possibility. When F is zero, this friction is also zero.
Okay.
So in that case, there are no forces, but still it is at rest. The value of the
Okay.
friction force is not fixed. It's the friction force maximum is mu into n. Okay, the friction force is like this. This is the applied force, and this is the friction force.
Mm-hmm.
When you apply a force small value, the friction force is small value. When you increase the force, then the friction force is increasing. Okay, but beyond a certain value, when you increase the force, the friction force has got a limiting value beyond which it will not increase. Once you cross this point, then the thing will start moving. So friction force is a variable force, but it will saturate after some value.
Okay.
This saturation value is mu to n.
Okay, got it.
Okay, and the direction of friction force is also not fixed. Suppose I'm trying to pull this way, then the direction of friction force is this way. If I try to pull it this way,
Hmm?
then the direction of friction force will change. So
Okay.
friction force depends on what is the net applied force on the mass also.
Uh, yeah.
Okay, okay, this momentum concept I want to explain, right? Okay, fine. Okay, can you answer this question? Is first law of motion a special case of second law? There are three laws.
The first law is that when the F net is 0, then the velocity is constant.
Yeah. So first law states that velocity equal to constant when F not equal to 0. Okay. What is second law?
F net equals to mass times acceleration.
Okay. So is first law and second first law is it a special case of second law?
Uh, mm, yes, because the acceleration is change in velocity by change in time. And there's no change in velocity in the first one.
In the second law, if you put F not equal to 0, implies that acceleration is 0, right?
Yeah.
And acceleration 0 means what? Velocity equal to constant.
Yes.
This is what is for first law, right? When F not equal to 0, velocity is constant.
Yeah, so it is a special case.
So second law is, first law is special case of second law, right?
Yeah.
Okay, so the answer is yes then. Second law, even when the net force is there, you can find acceleration using that. But when the net force is 0, it says the acceleration is 0. And that's exactly what is first law is saying. When the second law, if you put acceleration equal, F not equal to 0, you will get the information of the first law.
Uh-huh.
In the second law, if you put F not equal to 0, you will get the information just contained in the first law. Because F not equal to 0 means A is 0, that is V is constant. That's what first law says.
Yeah.
So even if you don't know the first law, just using the second law, you'll get all the information. Third law of motion, you know, third law of motion.
The third law of motion.
And there is one principle called conservation of momentum. So what you heard of the word momentum? What does momentum mean?
Yeah, it's like you get running momentum if you take a head start, like that.
Yeah, what is it defined as? Does it depend on the mass?
Yes.
What does it depend on? So it depends on mass. And what is the symbol for momentum?
I don't know.
Okay, it's represented by P. So it depends on mass, and does it depend?
How fast you're going, velocity.
Yes. So it's proportional to velocity. Anything else?
No, the friction.
No. That's a independent thing. So we define a quantity called M into V. Okay, and that is momentum. Okay.
Okay.
So momentum of a system is conserved. It will not change unless there is an external force acting on it.
Okay.
Okay.
Mm-hmm.
P of a system. What do you mean by conserved?
That it will stay the same.
It will stay the same.
Yeah. Unless a different force acts on it.
Okay. So here there is a figure. So there are two masses, right? A and B.
Mm-hmm.
Let's see the two masses, MA and MB. It's written right, MA and MB.
Yeah.
So MB is at rest and MA is moving at the velocity UA. Okay. So it will go and hit this one. Sorry, MB is also moving at velocity UB. Okay. And UA velocity should be greater than UB because it's going to go and hit it. So if UB is more than UA, then you cannot hit. Then the gap will keep on increasing. But UA should be more than UB, so it will go and hit. When it is hitting, there is a force FAB, force exerted by A on B, and force BA, which is force exerted by B on A. Okay, these two forces will be equal according to Newton's third law. And after that collision, it will start separating. And this thing, MB is moving with velocity VB, and MA is velocity moving with velocity V after collision. Initial velocity is called U, and after collision, the velocity is called V.
Okay.
It's a standard symbol. Okay. Right. So now this conservation of momentum says the momentum of the system before collision and momentum of the system after collision are same. Okay. So what is momentum of the system before collision?
So it's UA times MA.
Yeah. So momentum before collision I write as PI. I is for initial. So that is equal to MA into UA. Then anything else?
No.
Second mass is there, no? I'm talking about system. Momentum of the system. The second mass is there. So it is MB into UB. I'm talking about the system. Momentum of the system. So I have to add them.
Oh, okay.
Okay. Similarly, the final momentum is what? This is initial. What is the final momentum?
MA times UA plus MB times UB.
So this conservation thing says these two are equal.
Oh, so after the collision, it becomes the same.
Yeah. That's what we mean by conservation, right? Conservation does not change.
Yeah.
Okay. So PA and PF are same. But we have made a statement that if no external force acting on it. Okay. So, but in this process, going from before collision, after collision, at this stage, there is forces acting on it, right? FAB and FBA. These two forces are acting during collision.
Mm-hmm.
But we have said no external forces should act. Only then it is conserved. So, but still, I'm saying PI equal to PF. So, how is it justified?
Those two forces cancel each other out after hitting.
Yeah, these forces are called internal forces. It's within the system, right? There is no force like some external force acting on it. Within the system, there are some forces. A and B are within the system. They are internal forces.
Okay.
These are called internal forces because There's nothing from outside which is creating this force.
Okay. And forces from outside are called external forces.
Yeah.
Yeah.
So that's why there is no external force because the momentum is conserved. Okay. So with this understanding, we can try to the paraphrasing is clear.
Yeah.
We have 200 gram ball moving with a speed of 10 meters per second. It goes and hits a hockey stick. Okay.
Mhm.
And after hitting, its velocity will change, right? And the velocity is change and direction is change and the value is 5. Okay.
Yeah.
So what is the initial momentum?
10 meters per second.
Momentum, not velocity.
Oh, it's 2000.
You should be careful with the unit. Yeah, 2000. Write the unit as gram into meter per second. Okay. So in SI unit will be 2 kg into meter per second. This is SI unit. Okay. And what is final momentum?
25 gram times meter per second.
Don't skip the steps. No, tell the method. 2000 into 5, right?
Yeah.
So that is 10 kg meter per second, right?
Yeah.
So what is delta P?
8 kgs times meter per second.
Just tell the steps. Pi minus Pf, right? Pf minus Pi.
Yeah.
So what is this equal to?
8.
One important thing is momentum, is it a vector or scalar?
Vector.
So then the direction is important. When something is a vector, the direction is important. So Pi, the direction is what?
Right.
Okay. And Pf,
Left.
okay. So then what is Pf minus Pi?
8 kgs.
No. See, okay, once you fix the direction, so you take this direction as positive, left to right as positive. Okay. So Pf is then minus 10. Direction, no?
Yeah.
Towards right is positive. The direction can be taken care by the sign. And I am taking my positive sign as towards right by definition.
Okay.
I have to choose one of the direction as positive. Like x-axis, you have 0 in the middle, right? And one side is positive, other side is negative. Similarly, for vectors in 1D, you can take care of the direction of the vector by sign. 1D vector the direction can be taken care of by sign. So one of the direction will refer as positive, other directions will be negative. So Pf is minus 10. Okay. And then
So it's
minus,
minus 10 minus 2.
and then minus 2. So it is minus 12
Yeah.
kg into meter per second. So minus 2 means it is in the left direction. So the total change is 12, and you can say the direction separately towards left. Minus just indicates the direction. Okay, so you can see change in moment is 12 and the direction is negative. Or you can say minus 12. With this convention of towards right is positive.
Okay, yeah.
So whenever you get a problem, the important thing is to do this one. Once you have this thing, then the problem will become clear. And then another important thing is you don't have to read the question again and again because all the information that is required, I have converted into this language. And this language is easy to understand. And the way I am translating this could be different from the way you're translating it. It will vary from person to person.
Yeah.
So, but basically, you have to do this step, which is your own step in your own way of writing it. After this, you can proceed further. Okay, this one.
The bullet goes inside the block.
Yeah.
Okay.
First is paraphrase the problem.
Yeah, I did. I did it in my notebook.
Okay. And you have to draw pictures appropriately. This is bullet. The appropriate representation of bullet is like this. Gram, 150 meters per second. Right station within block. Okay. The bullet will hit here and then it will go to some distance. Okay. And so D is its distance, penetration depth.
Yeah.
Okay. So how do you find this depth?
First you have to figure out how fast it travels and how much distance it covers and how much time. And then, because you know the time is 0.03 seconds, you can work it out there.
So sorry, how do you get D?
I said you calculate how much distance it travels in 1 second, and then because you know the time is 0.03 seconds, you can divide it and see how much distance.
No. See the distance is the velocity. It's traveling 150. When it hits the thing, the velocity is 150. Let me call this as U. When it hits the velocity is at 150. Okay, meter per second. But after that, once it enters, the velocity will keep on decreasing. And at this point, the velocity is 0. Right?
Okay, yeah.
So we have to find the distance is known. So you can use this one, right? V square equal to U square plus 2AS. Whenever final velocity is 0, you can try the third equation, V square plus 2AS. And U is known, V is known, Z is 0, S is known. So from this you'll get A. You can find A.
Oh, okay.
So just calculate A.
Okay.
Sorry. V equal to U plus AT. V is known, U is known, T is known, so acceleration is known. Whenever V equal to 0, you have to use this something V. Okay, from this you get acceleration.
Okay. So U is 10 grams.
U is 150 meter per second.
Oh, right. Yeah, sorry. U 1 and time is 0.0.
So you have got acceleration
Yeah.
minus 5000. Okay, so once acceleration is known in the first, what I have chosen here, acceleration into the distance is depth. Now A is known, right? So from this you can find D.
Okay, so
This is not required.
is that 0 is equal to 15 squared, right?
Yeah, and A is negative, no?
Yeah.
There's a retarding force.
Okay.
So 150 square is 225 into 100 divided by 10. I think the answer is, the calculation is correct. It's 225 into 100, right? And then 100 will cancel with 5000 and make it 50. And 2 into 50 is 100. So it is 2.25 meters.
How did you get 2.5 by 100?
5 meter and 50 Newton. 2.25 meter and yeah, the force we have to find out. So this answer is correct. And then force is the uh, yes. So whatever acceleration is acting on the bullet, so that much force, the retarding force equal to m into e, right? Because the bullet is getting decelerated by some amount, and that decelerating force or decelerating acceleration is provided by a retarding force. So that will be m into e. So it's 10 gram. So in kgs it will be divided by 1000. into acceleration is minus 5,000, right? So 5,000.
Yeah.
So this will be 15 Newton. And it will be minus because it's retarding force. Okay. Basically, here it's not retarding. What is the force exerted by the block on the bullet? It is same as the force exerted by the bullet on the block by Newton's third law.
Oh, yeah. Okay.
So it is 15 Newton.
Okay.
Okay. Okay, we'll close now.
Okay.
Okay, see you tomorrow.
Yeah. Bye.